everyone, it's Justin again. Today in Science Club, we're using a signal transmitter. My friend Asher is in the library on the other side of the school, so I'm going to try and use this to send him a message. Let's see if the signal is strong enough to reach him. Asher, can you hear me? Nothing. Too weak. Good thing I have this amplifier that multiplies the signal strength by 2 to the power of 4. Asher, you there? Still not strong enough. Good thing I have another amplifier. This one multiplies the signal by 2 to the 3rd power. Asher, can you hear me now?
Justin, it's working. I can hear you.
Yes, it worked! Next time it'd be great to just use one amplifier instead of 2, though. But to do that, we need to know how much the signal was strengthened in total by the 2 amplifiers. Think you could figure it out? The first amplifier multiplied the signal by 2 to the 4th power, and the second multiplied that strength by 2 to the 3rd. So overall, the signal was strengthened by 2 to the 4th times 2 to the 3rd. We could probably use what we know about exponents to simplify this. Exponents represent repeated multiplication, so how can we write these as repeated multiplication? 2 to the 4th is 2 times itself 4 times, and 2 to the 3rd is 2 times itself 3 times. Multiplying these gives us 7 2's multiplied together. How can we write that as an exponential expression? Since 2 is multiplied by itself 7 times, it's 2 to the power of 7. So next time I can attach one amplifier that strengthens the signal by 2 to the 7th, and it'll give the same signal boost as when I used the 2 to the 4th and 2 cubed amplifiers together. Try simplifying x squared times x to the 7th power in the same way we just combined the signal amplifier strengths. First, pause the video to write the repeated multiplication represented by each exponent. X squared is x times x, and x to the power of 7 is x times itself 7 times. Altogether, that's 9 x's multiplied together, which is x to the power of 9. Take a look at both problems we've done. What do you notice about the exponents in the original expression and in the answer? Pause the video and write down what you see. The exponent in the answer equals the sum of the original exponents. This is called the product property of exponents. To multiply exponential terms with the same base, keep the base the same and add the exponents. Let's try this out. Use the product property of exponents to simplify each expression. Write your answer as a single term using a positive exponent. Pause to complete them. For part A, the base in both terms is b, so the base of the answer is b2. We'll add the exponents. 8 plus 3 equals 11. So the answer is b to the power of 11. We can see why this works by looking at the repeated multiplication. We end up with 11 b's multiplied together. For part B, the base is -6, and that stays the same. Adding the exponents, 5 plus 2, gives us 7. So the answer is -6 to the 7th power. And finally, part C. The base stays the same, h. The first exponent is 3, but what's the second exponent? Well, there's just one h, so the exponent is 1.
Adding the exponents, 3 plus 1, gives us h to the 4th power. Here, to multiply terms with the same base, we added the exponents. But does the product property of exponents still apply when we have 0 or negative exponents? This problem asks us to simplify 4 to the power of 0 times 4 squared. We'll try this problem using what we know about exponents first. Then we'll see whether adding the exponents using the product property gives the same result. What's 4 to the power of 0? It's 1. And how can we write 4 squared as repeated multiplication? It's 4 times 4. Putting these together, we get 1 times 4 times 4, which is equivalent to 4 times 4, since multiplying by 1 doesn't change the value. So this is just 4 squared. Does the product property of exponents give us the same answer? The base is 4, and we add the exponents. 0 plus 2 equals 2. Yes, we still get 4 squared. Now let's try one with a negative exponent. 3 to the 5th times 3 to the power of negative 2. We'll simplify using repeated multiplication first, then check whether we get the same answer using the product property. First, we'll write 3 to the 5th as repeated multiplication. Now, how do we rewrite 3 to the negative 2nd power with a positive exponent? We take the reciprocal and change the exponent to a positive, giving us 1 over 3 squared. That's equivalent to 1 over 3 times 3, which can also be written as 1/3 times 1/3. Since multiplication is equivalent regardless of the order it's done in, we can pair each 1/3 with a 3. What's 3 times 1/3? It's 1. So now we have 3 times 3 times 3 times 1 times 1. That's just 3 times 3 times 3, which is 3 to the power of 3. Does the product property give us the same answer? Adding the exponents, 5 plus negative 2 is 3. So we get 3 to the 3rd power, the same answer. Let's do another example. Use the product property to simplify each expression. Write your answer as a single term using a positive exponent. If the product property results in a negative exponent, use what you know to rewrite it with a positive exponent. Pause the video to try them. Starting with part A, the bases are both 8, so we add the exponents. Negative 3 plus 7 is 4, so we get a final answer of 8 to the 4th power. For part B, we add the exponents. 5 plus negative 4 gets us t to the power of 1. When numbers or variables have a power of 1, we don't write the exponent since no written exponent implies a power of 1 anyway, so our answer is just t. And for part C, negative 10 plus 5 is negative 5, giving us h to the power of negative 5. To rewrite our answer with a positive exponent, we'll take the reciprocal and make the exponent positive, 1 over h to the 5th. I think we're ready for a challenge. Simplify 3y squared times negative y cubed. This one has numbers and variables. Okay, what operation is happening between the 3 and the y squared? Multiplication. 3 is the coefficient, the number multiplied in front of the variable. Does y cubed have a coefficient? It does. The negative sign means y cubed has a coefficient of negative 1. So we could think of this expression as 3 times y squared times negative 1 times y cubed. Since multiplication can be done in any order, let's rearrange the expression to multiply the numbers together. Then the variables. 3 times negative 1 is negative 3. What's y squared times y cubed? Adding the exponents gives us y to the 5th power. We can't simplify anymore, so our answer is negative 3 times y to the power of 5, which we'll write as negative 3y to the 5th. Your turn to try one. Pause the video here and simplify this expression. Write your answer as a single term using a positive exponent. First, multiply the numbers. 2 times 5 equals 10. Then, multiply the variables. K has an exponent of 1, and 1 plus 7 equals 8. That gives us k to the 8th power, so the final answer is 10k to the 8th.
Thanks for exploring exponents with me today. We learned that when multiplying terms with the same base, the base stays the same, and we add the exponents. I'm going to go try my new signal amplifier. While I do that, finish your guided notes and practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, multiplying powers means adding the exponents. See you next time!
Hey!